Hello, dear children. Welcome to ninth standard online classes. We've been discussing about the equations of motion in the last period. Today, we are continuing the same with one more equation of motion, that is v square equal to u square plus 2as. In the previous periods, you come to know about other two equations of motion. What are those equations? One is v equal to u plus at and other one is s is equal to ut plus half at square. So we proved those two in the last two classes. Now we are deriving the last relation, that is velocity position relation or position velocity relation, which is given by v square is equal to u square plus 2as. So for that, yet again we are considering velocity time graph of a body moving along a straight line with uniform acceleration. So the same picture, or better you say same graph, we are carrying here also. So in this part, what we are doing is we are considering this point O, point A, point B and point C. This entire points constituting a quadrilateral called trapezium. So I will call this O to A to B, then B to C and C to O. This is taken as a trapezium. We call, or we take it as trapezium. So if you want to find the area of this trapezium, so what you will get? You will get the distance traveled or displacement. It can also give you the displacement. Yes, that is yes, small letter yes, and hence I can say that area under the, or you call area enclosed within the trapezium under the velocity time graph, that will be given by S is equal to area of the trapezium OABC. So I took this portion as OABC. We took it as OABC. Now what I am doing? I am calculating the area of the trapezium OABC. How do you calculate the area of a trapezium? So that is equal to half sum of parallel sides. It is given by sum of parallel sides of a trapezium into the distance between the parallel sides. So what does it mean? The area of the trapezium is given by sum of parallel sides. What are those parallel sides in this trapezium OABC? OABC, here OA is one parallel side and BC be the another parallel side. What you have to do? The area of the trapezium is given by half of sum of these two sides, into the distance between these parallel sides. So the distance means this. So you need to calculate the area, which is equal to half sum of the parallel sides. You can write OA plus BC into the distance between these two parallel lines or parallel sides, and hence that is taken here as OC. Therefore the same displacement S is equal to half OA plus BC into OC. OA plus BC into the distance between parallel sides OC. And you already knew that OA is equal to U. Okay, OA is equal to U and this BC as V, which is already known, and OC is equal to time T. So substitute all these values. What you are getting in the end? You are getting S is equal to half U plus V into T. You will get half U plus V into time T. So you are getting this kind of relation. I hope you are getting all these points up to this mark. The next step is using the relation V equal to U plus AT. From the first equation of motion, you can write for time. You have V equal to U plus AT. So what you have to do? Calculate it for time t. For time t, it can be written as just sending this u on the side where v is there. Therefore, v minus u equal to at. You left out with v minus u equal to a into t. Therefore, t is equal to what? T is equal to v minus u by a. Using that relation, for time, you can write v minus u by a. And once you got this value of t here, substitute in this equation. So what you will get? You will get S is equal to half u plus v, it is already there, and t is replaced by v minus u divided by a. T is replaced by v minus u by a. So just rearrange this portion u plus v as v plus u. It can be done, no problem. This is very simple step. Half into u plus v is replaced by half into v plus u into v minus u upon a. So what you are getting? One side v plus u, another side v minus u, and the whole thing is divided by a, keep in mind. So that a is entirely divisible, and hence you can write v plus u into v minus u divided by 2 is already there, and hence 2 is already in the denominator, so you can multiply 2 into a, and hence you are getting this step. So v plus u, v minus u is equal to v square minus u square. So a plus b into a minus b, what that kind of relation gives you? A square minus b square. Similarly, you can write v square minus u square. So s is equal to v square minus u square divided by 2a, and hence sending this denominator 2a on left hand side of the equation or expression. So you will get 2as is equal to v square minus u square, and hence you keep v square here, sending u square on this side and rearranging, you will get this relation v square is equal to u square plus 2as. So this is the third equation of motion. Okay, so what we have done, just for summary, I will take it once again. So you considered the area of the trapezium OABC. You considered area of the trapezium OABC as it is equal to S. Since the area under VT graph gives you the displacement, here this area is also belonging to the area inside the VT graph, and hence you will get this kind of thing, and hence I can say S is equal to OABC. That area must be equal to area of the trapezium OABC, which is equal to again the displacement S, and hence area of the trapezium is given by half sum of the parallel sides into distance between parallel sides. We took it as OA and other as BC, therefore OA plus BC into OC. Now substituting all the values for OA, BC and OC values, you will get S is equal to half U plus V into T. So for that t, what you have done, you used the first expression, that is v equal to u plus at. You written it for t, and hence t equal to v minus u by a. By substituting that value in the expression, you will get half s is equal to half u plus v into v minus u by a. So you will get v plus u into v minus u divided by 2a, and you can write s is equal to v square minus u square, as v plus u into v minus u gives that v square minus u square is divided by 2a is equal to s, and hence 2as is equal to v square minus u square, and you can write it as v square equal to u square plus 2as. This is the third equation of motion. So I have a simple suggestion for you to understand these kinds of equations, whether it may be first equation, second or third. You need to do one thing. You need to understand the graphical representation of motion. So if you know the graphical representation of motion, then you can easily get or you can easily derive these equations, or else it may leave you under confusion and making complex all those equations. Okay, so my suggestion is go through first the all the things which are related to graphical representation of motion, learn those, later attempt all these. Okay, I hope you got all these points which I discussed in this part. Dear children, let us try to solve some problems on the equations of motion. So the first problem, a body attains a velocity of 50 km per hour. A body attains or gains a velocity of 50 km per hour from the state of rest. From the state of rest, it is attaining such velocity, and that is in 5 minutes of time. So that will be 5 minutes of time. A body attains 50 km per hour velocity from the state of rest in 5 minutes. So you are asked to calculate, find the acceleration of that body. What will be the acceleration of the? Again, what you need to do? You need to write the given parameters. What are those quantities or parameters given? So first one will be, I will take it as u, because initial velocity u is equal to 0 meter per second. I write initial velocity u equal to 0 meter per second because I mentioned in the problem a body attains the velocity of 50 km per hour from the state of rest. It is started its motion from the state of rest, and hence initial velocity is taken as 0 meter per second. And final velocity of the body v is equal to, it gained 50 kilometer per hour. So you take it as even in terms of kilometer per hour, no problem. Kilometer per hour it is given, and later you can convert it into meter per second square in the end. Okay, so you keep it u is equal to 0 kilometer per hour, final velocity v is equal to 50 kilometer per hour, and time t is equal to 5 minutes. Now you written whatever the things in accordance with the problem. Okay, so here u is taken as 0 kilometer per hour, v is equal to 50 km per hour, and t is equal to 5 minutes. So either you convert the minute into hour, or you just bring all these into meter per second and second. Okay, so better if you take the acceleration in meter per second square. Okay, so I am writing 50 kilometer means 1000 divided by 1 hour means what? That is 3600 second. Okay, this much of meter divided by second, and hence it is equal to 50,000 divided by 3600 meter per second. So you can just cancel these zeros. So by that you can write 500 divided by 36 and go on solving this. That much of meter per second you are getting. And for t, what you have to do? 5 minutes. So 1 minute has 60 seconds, therefore 5 into 60, that is equal to 300 seconds. Okay, so you have and this is also equal to 0, no problem. You can easily write 0 meter per second as kilometer per hour into 0 is 0 yet again, if you want to do that. So just keep it as it is, since we already solved this portion. Okay, now you have solution. From the first equation of motion, equation number 1, you take it as of motion. So what it is? V equal to U plus AT. Okay, V equal to U plus AT. We want acceleration, therefore I am writing it for acceleration, sending U on this side. Therefore A is equal to V minus U, and T is left out here and sending on this side. Therefore V is equal to V minus U by T. So just for your further simplicity, just you write like this: V minus U, which is equal to AT, and hence you can write directly to this. I hope you are getting these things right. So V is equal to 500 by 36. So 500 by 36 means how much meter per second? 500 by 36 is equal to 13.88. You can write 13.8 meter per second, and on the other hand you have 0 meter per second. So 13.8 minus 0 divided by 300 seconds. So that much of this is meter per second already there, and divided by second, and hence you can write A is equal to 13.8 divided by 300 meter per second square, which is equal to 13.8 divided by 300, which is equal to 0.04 meter per second square. This will be the acceleration of the object in accordance with the problem. Okay, I hope you got this problem clear. The next problem: a motorboat starting from the state of rest on a lake accelerates in a straight line. A motorboat is there, a motorboat you take it as, which is on the lake. It is starting from rest and it accelerates in a straight line at a constant rate of 3 meter per second square. So it is moving with the acceleration 3 meter per second square for 8 seconds of time. So how far does the boat travel during that time? Okay, so how far the boat travel during that time? So you can write acceleration. Given parameters are acceleration A is given, A is equal to 3 meter per second square, and T is mentioned for 8 seconds, and it is motorboat is starting from rest, and hence U is equal to 0 meter per second. So what they asked for? They asked to calculate how far does the distance they asked for, S is equal to how much. So which equation of motion is going to suit here? Solution. So we have the equation is equal to ut plus half at square. You have second equation of motion, S is equal to ut plus half at square. Therefore, you want to calculate the how far does the boat travel during that time. That was the question. Therefore, you need to calculate the distance traveled by the boat. Okay, so this equation is suiting, I believe. So you write it as it is now. S is equal to, here U is 0 because they have mentioned very much clear that a motorboat starting from rest, and hence initial velocity will be 0. 0 into 8 seconds, which is equal to 0 again. Just to go on writing, acceleration is given, that is 3 meter per second square, and time is again this time 8 square. Okay, S is equal to 0 into 8 means 0 plus half 3, you write it as it is. 8 square means it is 64. So 2 ones are, 2 threes are, 2 twos are, and hence you can write it as S is equal to, you just ignore this 0. What you left out with? 3 into 32. So 3 into 32, 86 meter. You left out with 96 meters, since all these things are in meter per second square, meter per second, time is in second. So no need to convert. They cancel each other to left out m here, the meter, and hence the motorboat traveled the distance of 96 meter. So that will be your result. I hope you got this problem too. So in today's lecture, dear students, what we understood? We understood the third equation of motion and couple of problems. I hope you are following all those. I'm going to pause here at this point of time. I will meet you with some more problems in the next period. Till then, take care of yourselves. Bye bye.